You might have seen many of the embedded developers start their simple project development with Hello World. Have any time wondered why they start with Hello World? Hello World may be just sending a message on a screen, but it's a sanity check. What sort of sanity check? Hello embedded learners. I'm Geeta. I work as a technical director for ARM tools at GSAS Microsystems Private Limited. In today's video, I'll be actually showing the Hello World Basic project, which is a startup for many of the embedded learners. And I'll be showing the same Hello World on the display, and we will be blinking some of the LEDs on the board. So coming to Hello World is a sanity check. So what is a sanity check? That is basically to ensure the developer is in the right path, right track. What is that? To ensure the software what the developer has developed is correct, the code what he has written is correct, he has set all the compiler options correct, he has selected the correct compiler, he is able to build the project without any errors, he is able to flash the code to the board, and code is running as expected. So this is a check for an embedded developer to ensure that yes, the development environment or the development process what they have started in a right way. And if anything issue happens or any fault happens also, because Hello World is running, the developer can concentrate on debugging for doing any advanced debugging of the issue. Now let's jump to the demo. Before demo, I would like to just brief you about the hardware, basically not the hardware but the components which I'll be using as part of this video, and the part of the code which I'm using in the MDK software, which is the project given by ARM itself. So I'll be using the same project and I'll be showing the Hello World. So now let's start with the demo of this Hello World project. So before I start, I would just quickly briefly show you the hardware which I'm planning to use this for the demo. Basically, I'll not be explaining the hardware but the components which will be part of this project. Basically, because this is a Hello World and we are displaying Hello World onto the display, so our major focus will be on the LCD. So let's come to the hardware. You can see here we have connected a board based on LPC1768, which is Cortex-M3 MCU, and this is your MCU and this is your LCD. So how these both are connected? It is connected through SPI bus, which is on-chip SPI peripheral interface, and the SPI lines are used to drive this display from the LPC1768. And whatever code I'm developing in the Keil, I'm using this Keil ULINKpro debugger from ARM to dump the code to the onboard flash of the LPC1768 through this onboard JTAG connector. So I would like to take 10 seconds of yours to explain about LCD, because LCD you can see there is a internal light coming there that we call it as backlight. Compared to light emitting diode, LCD cannot drive the light or drive any output, but because it's a liquid crystal display, it uses the liquid crystal medium or a material to actually pass on the light through the interface. So now let's come to the software. So now let me take the example project which is given by ARM for the board, LPC1768 Cortex-M3 board. And this board is from our own GSAS make, which we actually give it for educational colleges, engineering, basically as a part of microprocessor trainer and microcontroller trainer kit. So now coming to the software, I'll be using the popular IDE, which is well known in the embedded market or by the embedded users, which is Keil MDK software. So this particular project, I'll not be going into depth of it. I'll be just initializing the LCD part here, because this LCD vendor has given the drivers and we are just sending the data, controlling the LCD through the SPI bus, and the data is also sent through SPI bus only. So now quickly we will just build this project. So now that I have built my project successfully, it has created the EXF file. So now I load the code to the board. So it's downloaded now, and so you should be able to see the Hello World on the LCD display. So now that we've seen how Hello World can be displayed on an LCD display, you can also display Hello World through UART or you want to display it on a screen, you want to display it on your Keil IDE, you can decide that, and you can drive the display wherever you want to see the output. Now that we have completed Hello World simple project, let's now go to the LED part, which is we'll be blinking the LED on the board what I've connected. So it's the same again, GSAS LPC1768 board. The board has 8 LEDs which are connected to the port 0 and port 1 pins of LPC1768 microcontroller. You can see the LCD display here, and you can see that LEDs and LEDs is what I'll be blinking now. So now let's come to the software. So this again, I'm using the sample project which is given by ARM. So I'll just build the project. It builds fine. Okay. So first we will check whether ULINKpro detects the hardware. So on the left side you see the ULINKpro details. On the right side it shows the JTAG debugger what I've connected. Keil ULINKpro detects the 4-site hardware which is my LPC1768. So now we will download the code. So it loads the code, and now I can enter the debugger and I can give the run command, or I can directly press the reset. So now you can see the LEDs is blinking. So this is the blinking of the LEDs. So because these LEDs are connected to the GPIO pins, we are directly sending the data for blinking of the LEDs. It just blinks the LEDs by left to right in a continuous infinite loop. That is a simple program. Hope in this video you might have got an idea how an Hello World can be driven on an LCD and how easily it is possible to blink an LED on the board. It is just through controlling through GPIO. Even for the LCD, I have configured it through SPI. So there also I have to configure the GPIO pins to tell the microcontroller that it has to be run as an SPI bus. Thank you and stay tuned for the next video. See you soon. Bye-bye.